All right, this is the first live stream. I'm sure absolutely no one is watching, but that is okay. For some reason it disconnected earlier, but all right. So, if you don't know, which you probably don't, my name is Wiley Davis, and I am the owner of a company called ClickRigs, and basically we make it's like a toy construction system for building toy off-road trucks, kind of gravity-powered things, but with real working suspension. And kind of like Legos, you can basically mix and match all the pieces. So you can build the rig as it is, or you can use the pieces to create your own rigs or modify your rigs. All of the parts are 3D printed. We use that. We have a 3D printing farm that we manufacture, and then right here, I obviously do all the prototyping as I design. So this series of live streams, I'm basically going to do it Monday through Friday, 8 to noon Pacific time, and we're just going to go through and kind of document the design process and the thinking behind these things, and just generally talk about off-road racing, automotive stuff, CAD, 3D printing, sometimes machining, and just kind of design in general. So that's what this is all about. And so today, I think we're going to be working on a new trophy truck kit. And let's see, we have one in the store now. Speaking of which, so a lot of the rigs we're working on aren't in the store yet, but a lot of the rigs already are. So you can go to ClickRigs.com and you can purchase these kits and get them to play with for yourself. And so there's a rig called the MDRD01, and that stands for the Mayday Race Desert version 1. And just a little bit of backstory. A lot of these rigs, unless it's like a collaboration, but for the rigs that I design, there's kind of a backstory, and it's a town called Harley Dome, Utah, that due to an unexplained event became isolated in this gravity warping bubble. And so the small town was sort of an off-road mecca, and in 1989 a bubble descended over the town, completely isolating them from I guess the really kind of the rest of the universe. But it created a sort of strange physical anomaly in that if you left town in kind of one direction, or basically the town was split in half. So on the right side, if you basically left town in any direction, you would basically be going downhill the entire way, and eventually you would loop back around to the other side of the town. And so they basically started calling them gravity threads, or gravity loops. And because when the town was isolated, it was kind of a heavily off-road and kind of truck oriented culture that just kind of continued. And so all of the rigs in town are essentially gravity powered because they don't really have gasoline or diesel or the ability to make fuel. And so the kind of ClickRig system developed so that they could kind of iterate and modify and build these vehicles to go run these gravity loops, which is kind of like basically an off-road soapbox derby through the desert. But then when they crashed, the pieces would fly apart and they could reuse them. And then there's this is kind of long-winded, but then there's a entity in town basically called Secret Facility. And it was, prior to the bubble descending, it was a research laboratory. But they happen to have the ability they have these full-size fabricator machines that let the town create new things kind of out of a couple materials. And so it's kind of like an analog for 3D printing. And so even though they're resource constrained, the entire town's culture is built around this whole concept of kind of running these gravity loops and competing for kind of credibility and respect based on like how fast they run them, or for certain groups, the stunts that they run. But anyway, we'll keep talking more about the backstory. But the point is, a lot of the rigs, in my mind, when I set out to design it, are designed for a character in the Harley Dome world. And so I will grab the Mayday kit. Here is, as you can see, pretty much modeled after a trophy truck. It's got triangulated 4-link rear suspension, unequal length A-arm front. Pop this hood off here. And so this kit belongs to a character named Mayday, and she's an orphan, and she's sort of a design, off-road design genius, but she is what you would call, I guess, very under-resourced. And so she's scrappy and kind of comes up with designs that a lot of other people in the town end up copying, but she has to kind of cobble them together from whatever part she has access to. And her driving style is pretty gung-ho. She designs rigs that she can just kind of point at the obstacles and just plow through at top speed. But because she's under-resourced, and because she kind of has to cobble together a lot of the parts, her rigs also require a lot of maintenance. They hold up, but after each race, she's spending a lot of time and energy essentially rebuilding everything. And that's kind of how this kit functions. It was designed so that if you have a nice clean run, it will hold up. But if you crash, the hood is going to go flying off. If you land sideways, the link connections will break. And by break, I mean they come apart. The ClickRigs system is designed so that it's very rare for an actual component to permanently break, but they are designed to sort of simulate crash damage. And so if you have a crash when you're playing with it or running it down a ramp, chances are high that like a component will come undone, and you'll have to rebuild it by kind of putting everything back together. And then even in between runs, even if it's clean and nothing actually breaks, you'll find that the little connections will sort of loosen up, and you have to prep your car by snapping everything back together tightly. And so that's kind of the Mayday trophy truck. And in the world of Harley Dome, she sort of innovated this whole layout, this unequal length A-arm and the triangulated 4-link live axle rear suspension. And so her nemesis is a fellow named Thorne Buckingham, and he's kind of he's got a rich dad, and he is definitely not under-resourced, and he's kind of obnoxious. His only saving grace is that he actually is a really good driver, but unlike Mayday, he's a very controlled driver, and he really doesn't like working on vehicles, and he doesn't like basically having to deal with any sort of repair or fix or adjustment while during a race. And so the design of his kit is going to be basically the idea is he has seen what Mayday has come out with, and because this design has been so successful, is basically going to steal every good idea that he can, but he's going to throw a lot more resources at it, which means his rig is going to kind of be much more refined, have a lot more bespoke or custom parts on it, and hopefully for him will also hold up to kind of crashes and abuse a lot better and require a lot less prep in between runs. And so that's the rig we're going to kind of like work on today, is Thorne Buckingham's Desert Racer rig that he's essentially commissioning to compete with the Mayday rig. And so we're gonna steal all the good designs. We're gonna kind of refine them, clean everything up, do a lot more like very specific custom parts with an aim to make it a lot less maintenance intensive, and maybe just a little bit like cleaner and sleeker looking. And so that's what we're gonna do. Let's see. So let's jump into Onshape. And so that is what, just so you know, that's what we use to design all of the ClickRigs stuff, is Onshape. It's a cloud-based, runs entirely in the browser, 3D CAD application that is really quite amazing. It actually originally, I believe, came from the same folks or same person that originally founded SolidWorks, I believe. So if you know SolidWorks and like SolidWorks, there's a lot of similarities. It's parametric CAD, but it I think has a lot of significant improvements. Plus it also runs in a browser, which is kind of rad. So let's see. This is kind of our ClickRigs setup area here. I've got a few documents here that this is the ClickRigs kit generator. It basically gives us some basic layout. I'm still working on these, but I've got the model catalog, which we can jump into that. That's basically all of the existing parts in the ClickRigs system. And so you can see there are quite a few. And so when we're designing a new rig, if we're not going to redesign the same part, we'll reuse kind of other parts from the system where we can, and then we'll just design whatever new parts that rig requires. So I keep this open. This is just kind of like a catalog of parts that we can drag into our design and use and not have to redesign. But when we do need a new part, we've got the ClickRigs component generator here, and that essentially lets us relatively quickly build new components. And so let's kind of go through. This is actually a good place to sort of talk about initially how basically the structure of the ClickRigs system. And so let's see. Let me actually grab a simpler one here just to illustrate. So the ClickRigs system, this, by the way, is another Harley Dome rig. It's called the FP01 Flying Pancake. And it's essentially, it was created right after the town was isolated in the bubble. This rig was created by Secret Facility and essentially just issued to everyone in town. It was sort of like a gift to the town to endear the town to Secret Facility, because there's a lot of suspicion as to what this kind of secretive laboratory had been up to. So Secret Facility created the Flying Pancake essentially as just super basic, cheap utility transportation that was gravity powered and sort of based off the ClickRigs modular system. So anyway, this is pretty much the most basic kit in our system, the Flying Pancake. And so let's just pull these off and we'll talk about the structure. And so you can kind of see, let's go to the browser here. We've got in this component generator, we have chassis, we have connectors, and we have caps, and then some like wheel and axle parts. And so we'll start with the chassis. And so the way the ClickRig system works, and because again this is a modular system, so each one of these rigs is not meant to be just a standalone entity apart from everything else. All of the rig kits fit within the modular ClickRig system, which means that parts can be interchanged quite readily to build new things. And so the way it works is, I'm kind of show you here, the chassis components, which I'll just kind of break this apart here. This is a chassis component, and what that means is it has the snap dot receptacle on both sides, and it is 10 millimeters tall. So 10 millimeters, and then essentially snap dot receptacle on each side. Now, the way it works is that the chassis is sort of like the midplane of the car, and you can build up or you can build down from the chassis. So the chassis is kind of like almost like a backbone that runs through the whole plane. And then you have what are called connectors, and we'll go to that and just to show you here on the browser real quick. So this is a chassis component, and so essentially what defines a component as a chassis component is simply that it's 10 millimeters tall and that it has the snap dot receptacle, the female receptacle, on each side of it. And then when we go to a connector, so we have chassis, connectors, and caps. And so the connector is defined by a couple parameters. One, it's 5 millimeters tall, and it has a snap dot receptacle on one side and the snap studs that go into the receptacle on the other. And so you've got a chassis component, and by the way, they don't all have the shape. Again, what defines a chassis is that it's got the receptacle on each side and it's twice as tall as a connector. And so we can kind of see some of the components in here. It's like this is a chassis component. This is a chassis component, whereas these are connector components. And so, as you can kind of see, studs on one side, snap dot receptacle on the other. And what that allows you to do is again build kind of up and build down. And then you've got components that are usually kind of the wheel, the tire, and the suspension components. In the case of the FP01, this is about as basic as it gets. It's basically a swing axle design that just flexes. So it's not the highest performance, but it's dead simple and super reliable. It's pretty much unbreakable. And then our wheels and tires, the tires are a 1/18 scale RC off-road tire, and then the wheel and the bearing is just a 608 skate bearing. And so you can kind of get all kinds of different bearings for that. And so the suspension components usually go somewhere in the kit. You've got your chassis components, then you've got your connector components, and then what you've got is something called a cap. And a cap is essentially, it's like a connector, but it only has the snap studs on one side And on the other side, it basically terminates the ability to keep building. So if the way the layer system works, you've got your chassis, and then you can keep adding connectors top and bottom, so up or down, and you can just keep stacking and building with connectors as many layers as you want to go. But at the very top and the very bottom of those layers is a cap component. And a cap component essentially means it's got studs on one side, and then the other side terminates the modularity of the system, because you can no longer reliably snap. They're not designed to have things snap on top of them anymore. And so like this skid plate component here is a cap component. And you can see like you essentially above that you can't put anything else on. And so another cap component would be something like this fender, because again it sort of ends the modularity of the system. Another cap component would be this cab, because even though it has snap dots on top, you can see it breaks the 10 millimeter by 10 millimeter grid, which means like you can no longer snap. You can snap little things on, but not any of the components, and so that qualifies as a cap as well. So we'll jump into the browser real quick. So yeah, we're just looking at the connector. We've got chassis, we've got connectors, and we've got caps. Again, that's a cap. Snap studs on one side, so they can snap on top of or on the bottom of a connector, but terminates the build system. So the whole thing is really, at that point, kind of like it's like a layer cake. You've got the chassis backbone, which can be built off of up or built down. Then you've got connectors, which you can just keep stacking to your heart's content up and down until you've got the design you want. And then you've got caps, which sort of finish off the top or the bottom, but you can't continue building off of. And so those are the three main styles, actually four, because you've got chassis, connectors, caps, and then suspension components, which are like, the A-arms, the springs, links, things like that. Basically the things that flex and move or are part of the suspension are sort of their own category. But you've got caps, you've got connectors, you've got chassis, and you've got suspension components. And so that's kind of the structure. So pretty much every rig or component is going to fall into one of those categories. And so that's how that works. So to generate kind of a new rig, I've got this bare bones kind of kit generator. So I'm just going to duplicate this. I'm going to duplicate it into kits. We're going to call this the TB Thorn Buckingham Race Desert 01. So this is going to be kind of his first foray into building a trophy truck style rig so that he can beat Mayday. And then the 01 is just the version designator. And so the idea is that we will occasionally sort of upgrade the version, kind of like, like a race team coming out with the next generation of their car. And so, for the Mayday rig, the next generation would be the MD RD02, and it will sort of supersede the 01, which will make that rig no longer available in the store. But part of kind of the ethos of the ClickRigs system is that every component that we've ever made for any of the kits will be available as a replacement part or just a buy to make new things. And so just because the version gets superseded doesn't mean that those components won't still be available. It just might not come as an entire kit anymore. So let's create the TBRD01. Okay, so really all the kit generator does is it kind of gives us a essentially a basic layout with a single chassis component and 4 wheels and tires kind of in the right spacing. And let me pull this sketch up here. And so this is kind of the way that, again, the system is built. And so the entire ClickRigs system is built on a 10 millimeter by 10 millimeter grid pattern for the snap connection. So basically the distance between here and here is 10 millimeters. And actually I just noticed, let's switch. I got my units in imperial. Switch these to millimeter. I kind of work in both depending on what I'm making. But for ClickRigs, everything is metric, which also works out nicely with 3D printing because you can kind of design the components to match like specific layer heights or wall thicknesses. That's good. So yeah, so if I click kind of these 2 points, you can see down here it's 10 millimeters. And that's true in this direction as well. So 10 by 10. And to aid with design, this sketch basically just gives you a grid to help design components so that as you design them, you know that everything will kind of match that grid system and will be able to snap into other parts. Let's leave it on for now. And then this is just kind of, again, this doesn't do it all for you, but it just kind of gives you a little bit of a head start. And so we got these parameters. So for the chassis, kind of a front wheelbase grid, and this is the number of grid steps. Rear wheelbase, so basically how wide is it here, and the front wheelbase, how wide is it here. And you've got front track, which is from the center point, how many steps in the grid forward is the front axle, and then the rear, so how many toward the rear, so you can kind of bias those around. So I think we're going to kind of pattern it off what the Mayday kit is. Let's see if I have that in here somewhere. It's probably this one. I don't know. Let's see. So let's see what you can kind of see that's the suspension layout. For the MDRD01, let's go to the parameters and just kind of see what we're working with. I think I might make it a little bit more compact because, again, Thorn is a kind of more of a precise driver, and he'd rather avoid hitting an obstacle, whereas Mayday just wants to like not think about the obstacle and just be able to like point the truck right at them and just soak it up, whereas Thorn is kind of more of a avoid obstacles where he can. So having a little bit narrower, a little bit shorter of a vehicle will probably suit his driving style a little better. But we are kind of copying all of Mayday's good ideas here. So probably the same, 5, 5, 9, 10, and 10, 5. So that's the 5.5 is basically 5.5 grid steps, and for this, you don't have to completely, the components have to adhere to this grid pattern, but the actual wheelbase and track width don't. So I'm curious if we maybe, let's just make this 5, just a little bit narrower. No, that was the wrong one. Front track. 9 might be too narrow, but we'll start there. And essentially, I'm just typing in. Let's shorten the rear. So I kind of like the front. I think we're going to kind of stick with that scenario. But the Mayday one is pretty long, and the rear. So I think I want to just shorten up the rear links a little bit. So we're going to do the rear. There you go, 8. Shorten the whole thing up by 10 millimeters. And I think we're going to make it, the front, kind of make it equal length. The Mayday rig is, the rear is a little bit wider than the front, but Thorn likes symmetry, and so we are going to I'm just kind of getting a feel for like the balance of that. I think we're actually going to make it a little wider. Let's go to the 10. Let's make it 10 and 10. Yeah, I like that. Okay. Okay, so again, a lot of design time is kind of just sitting and thinking. You're solving a puzzle or kind of figuring out what it needs to be, but that gives us a starting point. Just trying to think how much we want to okay, so one of the weak points, I guess, or one of the common failure points is this upper, this ball joint on the front suspension upright, on the top of the upright. It likes to kind of, basically, in a crash, it will become separated and break. And so I think one of the things I want to do is see if we can find a way to eliminate that altogether. And so I think right now we're going to let's work on the front end here. And so the way this kind of works, you've got let's kind of pop this. Let's take this. This whole assembly is essentially a few components. So you've got, let's just take this apart here. You basically got the lower A-arm and upright assembly, and that's kind of all one component, which makes it this flexible material, which is, it's a TPU 95A, is incredibly durable. You know, this stuff does not break easily, and so having these kind of be manufactured as one component, and you can kind of see the pivots come from just a thin layer, and so having this be all one component makes this assembly incredibly durable. It basically holds up, and that gets printed kind of flat like that. And you've got the butterfly spring and the ball end links, and then you've got two individual upper arms. And I've got the heavy duty connector pins. So essentially you've got just the upper arm. Now what I'm wondering is if there's a way that we can print this essentially so that this component is part of this, just like the lower arm is. And my first thought was if we get rid of this integrated boss, how would we do that? Could we basically lay everything kind of flat that way and print it? Again, a lot of design is just kind of looking at stuff and just sort of letting your brain churn. So essentially, if we kind of lay it flat like that. I don't know. I'll have to. Oh, we've got somebody who wants to know. They want to know what my name is. Except my name's Wiley. This is ClickRigs. Hi, Kabduwasik. I'm good. Anyway, let's keep working on this here. So I did do, let's kind of look at this thing. Yeah, so I think what I might do, we're just going to modify some parts here. So let's go. Let's bring some parts in from the model catalog. As you can see, it's not quite in the right place because we changed some of the size, but let's play with this for now. Okay, so again, we're just kind of like, we're going to very crudely just start kind of like hacking at things. So I think the first thing we're going to do is bring this down because again, if we're going to print it flat, this surface and this surface have to be similar. Like I said, a lot of this will be boring because I'm just kind of, that's design. You don't always know exactly what you're shooting for. You just kind of got to like play with it and look at it. And I think Hey, Brandon. I'm using an Ozbot, actually two Ozbot Tail 2s. So one overhead and one right there. It's got the little AI tracking nonsense going on, but it kind of works. And then switching it all through Ecamm. So now the other option that we could do, we could make this all one and then print it with supports in between, which I've done in the past, but just for production purposes, we kind of have ClickRigs kind of design constraints have a few rules, I guess, that I should mention, and that is all of the parts need to print with 0 supports, and we really only use 2 materials, and that is a TPU 95A and a Polymaker PLA Pro. And so those are kind of the constraining parameters and that make it kind of a fun game to design these parts. So trying to do everything with no support and just those 2 materials, and yet create, a fully functional kind of off-road suspension toy truck is kind of a fun challenge. Let's see. And again, apologies for maybe not being more entertaining, but we're going to do this Monday through Friday, 8 to noon Pacific time. We're just going to go through. So if you enjoy watching someone design and print toy truck kits, this is the place to be. Okay, so in order to kind of do this, one of the things we're going to have to, basically in order to be able to get the upper and the lower arms to print all in one piece and then kind of unfold, we won't be able to design it in the, I guess, the folded state that the truck will actually use it, because this will essentially need to rotate 90 degrees so that we're not having to print this height. So I think what we're going to do is we're just going to design a brand new component. So let's turn the layout on. You can see we got the top plane is in the middle. We're going to do a new sketch here. And I'm going to hide these for now. And we're going to base that. We're going to put our uprights here and here. Okay. And this is the first stream I've ever done, so I've got through Ecamm kind of the comments show up, but I actually don't know. I don't know. Can I turn this thing on here? This is the first stream I've ever done, so I've got through Ecamm, it's kind of the comments show up, but I actually don't know. I don't know, can I turn this thing on here? Like I said, I don't know if shows the comments, but it doesn't show if there are actually people here or not. So if you've commented and I'm responding to you, and you're not here anymore, I guess that just is what it is. But I guess back to Cab de Wasik. What am I doing? I am designing a new toy truck rig kit for my company called ClickRigs at ClickRigs.com. So that's what we're doing. And right now we are designing kind of a new trophy truck kit called the TB-RD01 for a fictional fella named Thorne Buckingham who lives in the fictional town of Harley Dome, Utah, that has been isolated from the rest of the world by a strange gravity bubble. If that makes sense. Stick with me for long enough and it will probably make sense to you as well, but it makes sense in my head. Okay, so, but right this second, we are trying to design, basically we're trying to redesign this double A-arm, unequal length A-arm front end so that it is all one piece instead of having a separate upper A-arm. So that's what we're doing. Let's do a little center line there. And then that's right where I want the upright to be. And these circles are essentially the outer perimeter of the various components so that they don't interfere with any other components that are snapping into any of the holes. And so I'm just gonna use those. Let's make them not construction lines. And so right now we're drawing the lower control arm. And I'm just trying to visualize in my head here. You know, in this one, I don't know if you can see that. This surface is goes on the build plate, so it's printed kind of like up like that, and then kind of all the A-arm and all the features build up this way. We're gonna have to flip that around, and so it'll be more like on the truck that's up, but this side is going to be, because this upright needs to go that way. We're probably gonna flip it like that. Again, this having somebody watch over your shoulder makes you feel kind of dumb because you don't know exactly what you're doing at any given time. But we are just plowing through it, and maybe after all this is said and done, I'll do an edit of all the highlights, and it'll make me look super fast and smart. But for now, we're just gonna muddle through this and Let's make these tangent. Do a parallel relation here. This is kind of, let's get a rough idea. It's kind of 5.3. But again, Thorn Lake's kind of a more robust. So make those a little thicker. Just do that tangent. So in this area we need space for a snap for our ball end link. I can kind of show you that little hole in these ball links, and that essentially just snaps in there and gives you a pivot, kind of like a spherical rod end or a Heim joint, aka Heim joint. Okay, for now I'm just going to mirror that. We can always go back. Right now we're just testing the concept to see if the premise of printing if we can figure out the premise of printing it as a flat assembly that then gets folded up into an upper and lower arm, all as one piece. We're just trying to figure out if we can make that work. We can always go in and kind of like restylize and make these cooler looking or more refined. But for now, we just want to get to the point where we've got a prototype component that we can throw on the printer and see if that concept even works before spending too much time making it pretty. So we're just going to keep that symmetric, keep these parallel, pretty straightforward. I'm going to be good and label these. If I'm moving fast, I don't always. With parametric modeling, it's kind of dirty modeling and then good modeling. And you can think of a parametric model as really, it's sort of like building a machine that generates 3D geometry. And if you do it well, that machine can be pretty versatile, and it can allow you to like use parameters or to go in and make changes really easily. If you do it dirty, which is much faster to do, the model quickly becomes a nightmare to work with. And both strategies work. It just depends on what you're going for. I find a lot of times I will start out sort of really, really dirty and just kind of speed through the thing and not label stuff. And then once I kind of have everything figured out and something I generally like, I just go in and remodel the whole thing from scratch, but make it nice and clean. If I think I'm going to be like working with that model again in the future or using it as a basis to build other things off of. But you know, right now, let's just stay dirty. And so we won't label this sketch. But let's turn that off. Okay, so we've got this sketch. We need to do a couple more things to it though. Wrong sketch. We're just going to mirror these components. These sketch entities, I should say. Now we're going to do an extrude. And I forget what it is, but we're just going to extrude it at the pivot height, which I think is like 0.8. That basically gives us 4 print layers. Okay, so now we've basically got our web. These are going to need holes, so let's actually just add that in now. Basically, so it can attach to connectors. We're just going to, so what this layout, grid layout sketch is useful for. So these are all, just hit U for use. Theory, yep. Okay, so our upright is going to come up 90 degrees in the folded state, but in the flat state, it's going to fold that way. So I'm going to just hide these for now. Okay, so like I said, what we're going to do, we're going to build an upright that kind of goes up like that, but it has to be modeled in the folded state, which means flat off of here. And just to kind of help with this, I am going to change this face to just change that red. So this is our print build plate surface. Actually, you know what? I completely take that back. This is our build surface. This is why we add it, so we don't get confused. Which means the upright now gets built that way. My dog. Just been out running around, breathing heavy. So let's see. I'm going to keep the upright height the same, which should be, I guess we can make it a little thinner too. Let's make it 1, because this is Thorne Buckingham's rig, so it's going to be a little bit more refined, kind of lower, a little sleeker. And so on this one, the upright height basically has 15 millimeters between it, which is 1 chassis component and 1 connector component. I actually think we can shrink that down to 10, so that it's just 1 chassis component in between, and make that a little cleaner. And since this part is going to get folded 90 degrees, that is this component. And so this is the height. And then we're going to do a hexagon. For the axle. And if you're new to CAD, especially parametric CAD, the line colors in these sketches mean something. And so essentially when they're blue, it means they're undefined, or not fully constrained. When they're black, it means they're fully constrained. And you can constrain stuff by adding a dimension or by adding a relation like parallel or coincident or things like that. And so this sketch is black because it's fully confined or fully defined. Let's see, I don't remember what the hexagon shape, that's another thing that I'm going to improve. So on the Mayday rig, this axle that plugs into the bearing is round, and that works pretty well. But again, it's in order to make it so that you can get the wheels on and off readily, you have to make it loose enough that it doesn't require too much force. But because it's round, that also means that that fit allows these wheels to pop off in a crash much more readily. Whereas on something like the Flying Pancake, it's hexagonal, and so you can kind of make the interference fit a little bit tighter, still get it on, but have like just a stronger connection. Let's go to the model catalog and just see what size that hexagon is, because that's been working well. .361 millimeters. And so let's just up to this face. Let's do another sketch. Or I mean another extrude. It's 8 millimeters. I'm going to add it to this. So now again, we're printing off the red, we're printing up this way. And this whole thing is actually, it's in here upside down. So I guess we could have modeled this whole thing differently, but again, this is just a quick and dirty test concept. So essentially this piece here, kind of along a line that's along a line that kind of runs there, will fold that way. And then the top A-arm will fold that way. So that's actually, and this isn't quite right because we need a little more material here. We've basically got that part, which is about 8, but then we need some structure here. So let's see that. I'll call that like 10. So this extrude actually needs to be 18 because we need 10 plus another 8. And let's show this sketch again. Let's extrude one's going to go 10 the other way, just like that. Again, this is very crude. We're just going to test the concept, and then we will clean it up once once we like it and if it works. Now there are two strategies to doing these kinds of parts. We could also kind of model all these pieces as individual components in place, as in their folded state, and then essentially move all those components into the flat state, and then join them together, do a Boolean together, and make them one component for printing. That might have been easier. Maybe we'll do it both ways just to try. In fact, we could probably do that with the upper arm. Since this is cubic, we could just do basically design the upper arm off of here as a separate component, and then essentially move it over to here for the flat state. Let's do that. Let's just give that a try. So we're just going to do it off this sketch here. Let's go back and turn our layout on, because again, the upper arms are going to come in to these points right here because it's unequal length. Essentially, if they're equal length, the tire they stay straight up and down. They don't have camber change as the A-arm goes through its arc, and so you get a lot of scrub in and out, which is not good. It binds up the suspension movement. So you want it to kind of like camber in as they go up, even in a rig like this, which isn't turning. So throwing out handling dynamics just from a pure suspension bump absorption standpoint, you want it to kind of roll in a little bit so that it's not just having all that friction of scrubbing sideways. So we are going to pick up these 2 points. I could connect this, but I think we're going to leave those as individual. I'm just kind of looking how this one did it. Mirror. So now we can just kind of I'd kind of like these to be tapered. Let's see. Let's go back into here. We need to figure out this dimension, because basically this dimension will be the pivot distance. We'll call that 4 millimeters. And we need to make sure we have clearance, because this is where in this lower one, that's where the ball link will come up to connect to the butterfly spring. It's kind of like basically where the coilover would go. So we need in a real car. So we need to make sure that we've got clearance there. Let's kind of keep with the parallel theme. And we're going to do a new one right now, because we don't want it attached to this, because we're going to have to move it into our flat state. And also do 0.8 millimeters. It's going to be part doesn't really matter. Okay, so we're going to do a transform. We're going to transform this. We're going to do it by mate connectors. We're going to go from that mate connector. We're going to go to that one. Almost. Let's actually, I'm going to call that new. And then here's what we're going to do. We're just going to, I think we got that. We're going to mirror these parts. That didn't work. Oh, that's because that's probably better. And that mirror, as you can see, we added it, and we added it to this part, which did the join for us. And so now we've got this one component that we should be able to fold here and fold there around. So Right now, everything except for the uprights, though, is in the 0.8 millimeter kind of hinge thickness. So we're going to have to add material where we basically to make parts of this rigid so that we can make some of it rigid and some of it a hinge or a pivot where we want it. And so that'll be next. We could kind of print it as is just to test, but I think we might as well add some other stuff. Let's see. I need to go check on something. I don't know if I can. I don't know if you can pause these. We are streaming. Turn off the tracking here. I'll be right back. All right, I'm back. Turn on the tracking. Okay. All right, so like I said, we've got our kind of flat layout pattern now for the an ARM system that is all printed in one piece. We just need to add some stiffening. So let's and these should all be on the same plane. Let's just do a new sketch. Okay, so let's go back over into here and just kind of get a sense of the distances. The way almost all of the ClickRigs pivots work is it uses a flexible TPU, which is incredibly tough and kind of lets you essentially vary the thickness to change how much flexibility you want. So like in this lower A-arm, for instance, these thick pieces are, for all of the loads that these toys see, are rigid. And then these thin sections are the pivots. And so the distance kind of like from here to here is kind of a function of how much you need it to flex, like how the angle you need it to pivot at, and also kind of the floppiness And so if you make these too far apart, you get a lot of flex, but it's also very floppy. It can kind of twist more as well as just pivot. And so, but these have worked pretty well. So we're going to reuse that. So it's like 1.7 millimeters. Yeah, 1.7. So first, let's do the lower arm. So this bit, basically the chassis component will kind of span there, so there'll be a rigid section that snaps into. Just kind of give myself some reference lines. They're not totally necessary, but they help me visualize it. So that will be kind of like the one edge. And then this is where the rigid part will begin. So we'll make that 1.7. So that's going to be our gap. Just kind of do a center line there. Because we made these symmetric, which makes this easy too. We can just kind of design in this quadrant and then mirror it and then mirror it. Same thing here. Now, this is going to be a little interesting. I haven't done a part like this before, because normally this flat state would be the state that it's in, the configuration that the component is in on the truck. And so this part is flat until it's pivoting. But in this setup, we're actually going to be bending this 90 degrees from the start into the configured state. And so we may end up needing to adjust this gap. My guess is it might need a little bit more, just because we're going to be taking up some of the compliance just to bend it into the normal state. And that might make it too rigid. So I'm actually just going to start. I'm kind of curious. I don't know if we can zoom in on this here. So, our normal state is like this, but because this one is essentially going to be bent into that state normally. But that's not bad. I actually think we can get away with the same 1.7. So we're just gonna do that. We're gonna keep it as is. We can adjust it later. That's the beauty of prototyping. So I'm just using those edges and then I'm trimming them up. And we can make these a little bit pretty. Let's add some fillets. 1 millimeter. Let's make that one 2. Mirror that. Mirror that. And so now what we can do is we can extrude this up. And what I'm going to do is extrude it up, but with a draft. So it kind of, it's probably a little hard to see in this, but that's kind of what this is. It sort of angles in just a little bit, and it just kind of gives it a slightly racier look. So, and let's jump over to here. Just kind of, this thickness is pretty good too. 3.8. Add it. Go up 3.8. And then here we can select draft. We could do like 10 degrees. 20 degrees, kind of makes it more extreme. Let's try that. Oh. So you can kind of see there, starting to get some rigidity. Again, this, unlike this other one, unlike this one is going to be kind of oriented that way. So this will be the bottom of the truck, and this will be the top. And I'll do that with the upper arms here. I don't really like using that. Let's kind of define that. Trim these up. Add some beautifying fillets. Mirror that. And here, you know, because the upper arm doesn't take the spring and the shock loads, so it doesn't have to be quite as thick. So that one we made 3, so 3 versus 3.8. Again, we might change that. We'll kind of just see how we like it, but. I think that looks pretty good. So now we've got essentially what I hope will be a one-piece sort of origami, not really origami, but foldable upper and lower A-arm assembly. And the advantage of that is that these two pivots here should be very strong because, as you recall from earlier, the in the Mayday version, the upper arm and then the lower arm assembly are two separate pieces, and this pivot here is very strong, but this one, which is essentially this ball joint there, is susceptible to damage. So in a crash or a hard hit, a lot of times that will pop off. And so, because Thorne Buckingham does not like DNFs, and he does not like having to touch his car after a race begins, we are going to make that very strong. And so if it all works out, this should be able to fold around and connect. And because of the way we don't, so on this one, you know, we needed the room to be able to fit that little ball joint connector on the top. Because it's integrated, we might be able to actually get more travel for a given width, especially since we decided to make Thorne's truck a little bit narrower, because he likes to drive by avoiding obstacles. But the narrower you make it, you know, the less travel or the more angular change, which is bad, you need for a given amount of travel. But by moving, we might be able to move this pivot more outboard, effectively giving a longer arm length, because we don't need this structure to be completely outboard of the wheel and the bearing. So I actually might give that a try. Sometimes I forget to switch back to the browser. Apologies. I think we can adjust that. Let's call that 10. Let's call that 2. Now, something I might do here, I might add in a little bit of, could probably do that with a draft there. Essentially just a little bit of draft back, just like this, so that as these, although that actually won't matter because it's folding and pivoting the other way. I was going to say, you know, in a setup like this one, that draft is required so that you can kind of get the clearance for enough travel. Same on that side, kind of right there. But because this one is going to be folded like this, there actually is there's no potential interference, so we don't have to. I was thinking this surface needed to be backdrafted, but it does not. So that's in some ways kind of an upside, but I do wonder if we could make this look a little more polished, maybe. Again, this is just a quick prototype, but if you're going to print something, sometimes it's nice to add a few little finishing touches, even if you're going to end up undoing them all, because it doesn't take that much extra time to add them, and it does make the makes the print a little bit more satisfying when you pull the first one off. Even if it doesn't work, at least it doesn't look terrible. Okay, I think let's go ahead and throw this on the printer. One thing that'll be interesting as we capture this will probably be captured with a cap. Hey, bud. Okay. 2.6. So that'd be cool. So the cap will kind of like nestle right in between there and kind of give it a now for droop travel we will need that backdraft, but we've got that here basically so that these can swing down. Okay, well let's throw this on the printer and get that printing so we can try that out. Let's export this. As a step file. I'll jump into the slicer here. Got our presets. I like to look at the line type. It's a little garish, a little busy, but kind of gives you a sense of what's going on. And these don't really need 100% infill. But we'll bump it up a little bit. Cool. Okay. Let's see. I also I'm getting ready to set up an Airstream trailer with as a mobile kind of design and prototyping studio, and so as part of that, I made a basically an adapter plate that mounts a Bamboo A1 Mini 3D printer to a Milwaukee packout box. And so we're testing that out. I just kind of shoved it under there. There might actually not be enough clearance for the printer, but we're gonna try it anyway. See what happens. Pull these parts off the build plate. These are the Mayday components. See if I can find it. Oh, you know what? It can't, and it can't because for this camera setup, all these cameras are on an NDI and on a switch. And for some reason the cameras kept switching over to Wi-Fi when the Wi-Fi was on, but I am going to have to turn the Wi-Fi on, so 1 second. Actually, let's see if we can connect this to the Wi-Fi that is on. Seemed to like that. It should be on a fixed address, so let's see. Nope. Let's see. Okay, we might have it now. Looks a little better. Thinks it sees it, so that's good. Maybe. There it goes. All right. Let's jump back over to the browser here. All right, so just to catch you up, we are printing a prototype of this piece, and this is an integrated front trophy truck A-arm assembly that has the upper arms and the lower arms and the upright all printed as one component. This is for the Thorne Buckingham TBRD01 trophy truck. And I guess to give you, let's jump in, and I'm gonna, while that's kind of getting set up, we're waiting to make sure that the first layer goes down well. Let's jump over, and I'll just kind of show you around the ClickRigs website here. As you can see, we've got kind of a number of different rig kits. Let's start. I'll just kind of go through them here a little bit, and yeah, we'll go from there. Let's start with the one we've been that we're sort of emulating and doing a little bit of improvements on, and that's the MDRD01 desert truck. Kind of see we've got a few photos, and again, this is pretty much a trophy truck that you can assemble. It's like Legos, but for making toy off-road trucks. It's got a double A-arm unequal length front suspension. It's got a triangulated live axle rear suspension that's got these trailing arms, an upper triangle link, and then it's got these quarter elliptic TPU springs with a ball end link adjuster. And what that kind of does, you can kind of maybe see it better here. What's cool about this system is we have a kit that lets you swap these quarter elliptic springs in the rear and the butterfly springs kind of here in the front for different spring rates, so essentially different thicknesses, but also so you can adjust the spring rate, but you can also adjust the ride height independently by swapping out these ball end links for different lengths. And so I can show you that. It might be linked down. So like here's the tuning kit for any of the vehicles that have kind of this style of suspension. So you've got a whole slew of different quarter elliptic arms for the rear, and then a whole slew of different butterfly springs for the front, and then a whole, basically 4 sets of different ball and link lengths that you can kind of tune the suspension of this whole thing. Let's go back to there. And then if you kind of want to see, you can watch this video. This is some slow motion footage of running it down a ramp. And then another video on kind of how to build it. And then there's some like kind of other upgrade kits. Like this one is the truck we've been looking at has all these on it already, but these are kind of add-ons to the MDRD01. It's essentially a set of reinforcement pivot points, as well as a set of limit straps, which kind of help the whole truck. When it's flying through the air, it helps it keeps it a lot more balanced, and a lot more in control. And then we've got, obviously we've already talked about the flying pancake a little bit. This is the Harley Dome basic transportation. It's a super simple truck, pretty much indestructible. But we're going to be doing a lot of sort of mod kits for this. It's kind of like it's like a Ford Ranger or a Honda Civic of the Harley Dome world, and so you can go pretty crazy with the mods in kind of a ridiculous sense, but part of the fun is kind of seeing how far you can push the performance or the craziness of what is essentially a very basic non-performance rig. And then here's some video of the pancake flying down the ramp. It's a lot more wild. It just kind of bounces all over the place. But sometimes you get kind of a cool little run out of it. See, that wasn't that bad. Just goes to show you, you hit the right kind of jump just right, and you don't need a ton of fancy suspension or wheel travel, but also a lot less forgiving that way. And playing with these on the ramp is just kind of one style. You know, you can push them, you can jump them off stuff, you can roll them around. Yeah, all kinds of ways to play. But the ramp, especially if you film things in slow motion, is a really fun way to kind of play with these things. In fact, so here, speaking of modifications for the Flying Pancake, so here's a mod paradise collective, just sort of a group of hooligans in Harley Dome. This is a long travel kit for the Flying Pancake. And so it's essentially these components. You've got your classic flared white fenders, some long travel axles that move, and then some butterfly springs and links that essentially let you tune the swing axle on the Flying Pancake and give it a lot more travel. So it's a little wider. It's more freely pivoting, and it has some wider fenders and some other braces. So that's kind of a modified Flying Pancake. And then we've got, again, some different suspension types. So this is the K12 Rock Buggy, and it's our first leaf spring solid axle kit. And it's not really designed for going fast or big jumps, but it is designed for a good bit of articulation. And so you can kind of see here, leaf springs, some little light bar, and some jerry cans. And then this one's for pre-order. This is the Earl motor. So this is a collaboration with Alex Earl, who races a 1969, I believe, Jeep Commando, and so we essentially created a model of his race car in ClickRigs form, and so it's and this is right now this is the only kit that we have that comes with a decal kit as well, so you can apply all of the race decals. Again, this is also a leaf spring solid axle kit, just like the real car, but this leaf spring setup is a lot stiffer. Doesn't articulate nearly as much as the rock buggy, and it was designed more for jumping and desert style kind of high speed racing. I also have some cool packaging for it. And again, all these components, again, are part of a modular build system. So kind of like Legos, you can build this rig as it is, but you can also use all these components to build something new, or you can use other components to modify this. In fact, if we go to the YouTube channel, there might be a little video of, we'll scrub through this quickly, but
well, bad news is this. We've sold out of the FP01 Flying Pancake.
What's the good news?
There isn't any. Seriously? No, not seriously. Of course we're making more, but that's not the good news. What's the good news? Well, we've made a terrain building system.
Ooh.
We're going to call it Terranium, because that's a mix of the words terrarium. Well,
so this is kind of a little demonstration. We have the rock buggy going down a little obstacle ramp with the leaf springs, and then we're going to kind of modify this, and we're actually going to pull off. We're going to throw the trophy truck front A-arm suspension from the Mayday kit that we've just been looking at onto the front of the K12 rock buggy, and then kind of see the difference. As you can see, there's a lot more wheel travel and a lot more stability. Kind of versus this. So anyway, that's just kind of one example. You can basically mix and match and get parts and modify things and kind of see how they do. Anyway, let's get back to this one. Let's see. Go check the print here real quick. All right, seems like it's laying down okay, so we'll let that print. Will it be done today? We're streaming until noon Pacific time, so is that a couple more hours, hour and a half, something like that. So it might yeah, it should be basically 55 minutes left, so we might be able to test that part out today, which would be exciting. See if our concept works. Let's see. So trying to figure out kind of where to go from here. I'd sort of like to stay concentrated on the front end. Let's we don't need that in there anymore. I just brought that in as a reference. What it might be worth doing is making this component kind of in a fixed folded up state. I'm trying to think what the best way to do that would be. Maybe I'll just let's see, let's duplicate this tab. All right, let's hide everything else. So what I'm going to do is I'm just going to roll the timeline back to here, I think. Maybe we'll just delete these. And essentially what I'm going to do is I'm going to move these components. You know what though? We can't do that. Let's we're going to split. We're going to use the split tool. So I'm going to go split, and then I'm going to split that. I think I can. Boom. So now this part and this part are two separate parts. We're just going to keep splitting. There might be a better way to do this, but as far as I know, you kind of have to. Okay, so we should now have one, two, three, four, five components, I think. Let's see. 1, 2, 3, 4, 5. Cool. So now we can kind of transform stuff around. So let's start here where we're going to do this. I want to do that one. We're going to rotate this and do 90 degrees, and our axis is going to be there. Let's go the other way. Awesome. Let's do the same thing for this component. So that's roughly where it would be in its folded state. I'm going to do another transform, but we're going to just do this one by make connectors. Just like that. And do the same thing for the side. Rotate that. So now that's kind of essentially what our folded up state will be. These probably don't join. So we're just gonna kind of cheat it a little bit, and we're just gonna go. I don't think they'll join. We could try, but technically these connect at like a theoretical point, and so my guess is we won't be able to union these. Yeah, they don't intersect, so. I think we're just going to have to do a drawing, do a new sketch on this face. Let's keep it simple. Could probably do that over here too. And we'll extrude, and we're going to add it, and the merge scope is going to be you, and you, and you, and you. And we're going to go up to face, just going to go to this side. And now we have one part. Now we can go into our truck layout, and for now let's just hide this part. We're going to drive in the part we just made. And it's upside down. Let's create an assembly. Let's rename that there. Let's insert some components. Let's just do this whole thing. This one, for now, we will delete. I'll delete that. And I'm just going to make this simple. I'll select everything. Except for part 19, and we're just going to fix them in place so that they can't be moved. But now this part can be moved, and we are going to oh, you know what? I'm kind of dumb, but it's okay. Let's see, I think I've got a cap piece, so let's go into the model catalog. Let's find a cap that will work here for now. I think I want to use the we might make a new one. Let's just use the regular straight cap. That's 5. We got 2. We're just doing a make connector here. Turn that. And then we're going to do a make connector. Kind of roughly like that. And so one of the things I'm wondering is basically from here to here is going to be thick enough. It's like 2.8 to kind of give the rigidity that we need, but we'll find out. I think it will be. We can't really move anything inboard to give it that because that's our flat print side, so and we need it to print without supports. That's better. I guess one of the things we didn't add the little snap pocket for the ball end links, but we'll add that in the next go around. I'm sure there are other things we'll be wanting to change. So I'm just kind of looking through to check out the packaging. And so remember, hey, no barking. No barking, buddy. We made this 10 millimeters, which means it's essentially the same height as this, which means we might need some interesting, essentially we need to pick this up wider, but if we bring the chassis out that way, straight down, essentially, like if we I'll show you. Let's just remake this here. Let's hide the chassis. So you can kind of see, basically we need something that's 3 wide to pick up these points. The problem is if we do that and it extends out here, we've got clearance issues for this lower arm. Basically this lower arm won't be able to go into full bump without hitting, which is obviously not what we want. So we're going to have to figure out some way of making a set of chassis parts and connector parts that will work with this configuration, because we don't want to move this pivot outboard because that's going to restrict our travel, and then is also going to make it a parallel movement, which again gets us all that tire scrub. And so one thing we could do, we could have a tapered chassis that goes from 3 wide on one side down to 1. And again, this is the Thorn Buckingham rig, so we're not trying to reuse pre-existing components unnecessarily. If there's a reason to make a bespoke custom component, then that's what we're going to do, because Thorn Buckingham has plenty of resources to do that. The question just is how, or what's the best way to go about doing that. So basically there'll be a chassis component there. If we didn't want to make a custom chassis component, we could do a couple things. We could modify the arm setup so that this lower arm actually comes in here to give it clearance. That could be one kind of slick way of doing it. Or we could do a tapered center section. Tapered, or like a T. So like if you're looking at it here, we could taper this out, or we could come up and in. I don't think we have any pre-existing parts that do that. Okay, so we've got a couple options. The quick and dirty way would be to just cut out pieces of this chassis component. Which could be interesting. think we have that part here too. You know, let's jump into this is a good opportunity to use the component generator. So we'll jump over there, go to chassis, and the way this works is we basically, this is kind of our blank slate, or mostly blank slate. We're just going to, should be able to copy that to the clipboard, jump back over to here, paste that in. Let's call this tapered chassis for now. What's a neat way we could also build in the butterfly spring. One of the things, so on the Mayday rig, let's jump over there. This is the best place to see it. So kind of down here. The hood on this has to be, like the whole stack height, this whole truck is fairly tall or fairly thick, kind of in the height direction. And part of that is because this hood has to be so high to clear the butterfly spring and the ball end link when this is in full compression. Kind of probably see that here too. I'd really like the Thorn truck to be kind of a lot more low slung and just like much more compact height wise. And so that means we're going to have to figure out how to get clearance from this hood for the suspension, the spring, and the ball and link system. You know, one of the ways we could do that is we could essentially cut holes in here for the clearance and drop the whole hood down. But there might be something where if we do a custom tapered chassis component here, where we could invert the spring or bring it in a little bit lower. Because right now, like this is up. The butterfly spring goes in on top. But effectively, if this were inverted, we'd gain about 5 millimeters of clearance. So yeah, so let's you can go into master sketches, turn on the layout pattern, which gives us all the circles we need, and the chassis layout. And go into the sketch. So start over. It's going to give us our 3. I actually think we're just going to do it like this. And this kind of template, I built this to kind of make it easier to quickly rough out. So you can select those, you can click use, and then just kind of that gives you that, and then you select it and you go and fix all of the red stuff. So I turn off the layout pattern. That basically gives us our pockets. We could do a lot of this with feature script, but I don't really know it that well, and I think that's right. That's what I thought. Just double checking. It's been a while since I've used the component generator. And so, let's see. This sketch, essentially the top surfaces of the model. It's kind of nice to have some cutouts. But for right now, we'll just insert that component we just made. We don't want all the plugs, we just want that part. Okay, so kind of like that, and then if we just taper these, so let's go back into here. just getting a sense of where those pockets are. Add some relations. Okay, so let's do this. And a dimension from here to there, and that should be 5. And then we're going to dimension from here to here. I think it's 4.5. Let's just mirror that and see what that gets us. It's going to give us a nasty pocket, but that's okay. Through all, we're going to remove. So then we can fix that up since we don't need that anymore. But let's go back into the assembly. It's starting to look kind of cool. What that does, that gives us clearance for this lower arm to move up, but lets us pick these up. Kind of liking that. Let's jump back in. And so the way this chassis generator works is you basically make the, we'll show all the parts here and we'll show you what's going on. So we've got these are called snap dot plugs basically, and this is the shape of the cavity that needs to be in the chassis component or the connector component for a snap dot to plug into. And essentially this will let these are on the grid, so this lets you make a component and then do a boolean and subtract these plugs from the body, and that is this boolean feature here. And so what we can do is we can just deselect those 4. We're going to hide everything but that. And so now we don't have those cavities on that face. So that's pretty cool. Go back into the assembly. One thing I want to see is how wide is this? That's 9. Yep, so this edge is kind of flush with those. Kind of curious what the clearance. Yeah. So we could actually come up a little bit more at this angle. Part of it is I just kind of tried to make this height the same height as a connector, which is 5 millimeters, or basically like half. But Let's also clean this up a little bit. And so now we could add, if we wanted to, kind of a cutout here, similar to what we've got there for the spring, but we'll do it on the underside. Let's go, let's pull some dimensions here. So 10, and this should be 5. Yep. And so what we'll do is we'll give these a symmetric. And one little tip, if you drag this way, it will only select, basically if you drag from left to right to select, it will only select things that are fully enclosed by the box. But if you drag right to left, it'll select anything that it touches. And so you can drag right to left, select these 3 lines, and we're just going to do a symmetric, which about this center line. So now that means whatever it is going to be centered around that. So we just added a coincident line. That's just the I keyboard command. And then let's add a dimension to this. That's 5. And then let's just remove through all. Let's just delete this for now. Nope, that's not the one I wanted to delete though. Essentially, this sketch referenced that chamfer, which is not what we want. Why it's often good practice to do kind of all your filleting and chamfering last if you can. So we're just going in and we're fixing these sketch references that were broken. cleaning up those. So there are 4 of those snap dot pockets that we deleted. Let's make these a little less sharp. Cool, so now we've got the ability to throw a butterfly spring in there, and it's much lower. What's that? That's going to be interesting because it means it's essentially going to be right on top of that, which gives us a couple interesting things to play with here. Probably what we'll do is a really short ball end link there, much shorter than like are used on the Mayday rig. But that'll keep it all kind of compact, and it should keep everything inside the confines of the upper and lower A-arms, which will let us run a shorter hood. I do wonder what it looks like if we kind of like that. So what we're trying to do, what we're moving toward here, is a more compact and a stronger front A-arm assembly than this one. So this one is obviously taller, it's got a lot more packaging requirements. The leaf butterfly spring pokes up way above the upper A-arm. You got all this stuff kind of sticking inboard. You've got a connector here that is prone to failure and a crash or a hard hit. And so we sort of integrated this whole thing, moved the spring down, and then moved the entire thing in this direction 5 millimeters shorter. So it's like roughly a third of it out. We'll probably want to clean that up a little bit, and then we're going to need to throw the ball end link pocket into here. So let's go Let's hide that part. All right, hold on 1 second. I'll be right back. All right, I am back. Let's see. So we are going to add the ball and link pocket. And so let's see. Is that in the model catalog? My guess is it's not. It's not. Probably should be though. Wonder if it's in this one. It's probably in here. I'm basically looking, there's a plug. So similar to the plugs for the snap dots, there's a plug for the ball and link connector. There it is. Bring that in. And we're going to drive that in. And so now we're just positioning it. Basically, where that plug is just going to remove its shape from the arm. Just kind of want to see. Pretty sure we want it as outboard as we can. That looks pretty good. It's going to mirror this component. Now we're going to Boolean subtract. Tools are going to be those two. The targets will be that. And we don't need to keep the tools. There we go. And we've got a little receptacle for the ball end link. Which did not make it into here, obviously, because that one came from here. Although, I bet you I think our print is done, so sweet, we gotta check that out. That's right, because we just we copied this, we didn't derive it in, so it's not going to update. That's okay. Live and learn. Let's see. Grab some parts here. just kind of testing out the concept here. So far I am optimistic. Seems to work well. As predicted, we have some interference on that little component, but all in all, not too bad. And will be fixed by our tapered chassis part that we've been working on. So, very rough draft, but we'll connect this up. We'll probably get the next version printing. We need a snap dot in there. So I think that concept's going to work. So this one should actually be, it's like a smidge narrower overall track width, but probably has more wheel travel. So that'll be cool. And then comparatively, it's a lot more compact. So overall, I think it's a good start to the concept. What we'll do, let's see, how much longer do we have? Today we've got about 40 minutes left, so we can get some more work done here. But off to a good start. I think fictional Thorne Buckingham is going to be very, very happy with his new rig when it's all said and done. Speaking of that, I think, well, it's going to take probably at least a week, maybe a little longer to get this rig designed. So hopefully this week we'll have a lot of it wrapped up, and then from there it should be in the store pretty close after that. So I'd say within 2 weeks this kit that we're designing now will be available for purchase in the store at ClickRigs.com. So that's what we'll shoot for. I think over time we're going to do this every day, so we'll just keep releasing new kits, and we should probably start getting faster and faster at this. But I think we're off to a good start. So let's see, what should we do next? I bet in the 40 minutes we have left, we might be able to get the tapered chassis piece printed. So let's start there and just get that printing. Just kind of wrap this up. I think it's probably good enough to print, so we can export that. And let's Let's run on this one. Remember, we're going to have to reconnect these printers. We did it for the one. Let's do it for the other one here. The key on these Bamboo A1 minis are also super mini, and I don't have like the fattest fingers, but it's still very difficult to type a password in. But we'll get it done. Let's see if that connects. Looks like it. Let's jump over to the slicer. Let's do a new tray. Good enough for now. Let's go, let's see, that should be 0B. Sweet, that one connected. Let's print it. I haven't done, let's do all that. 23 minutes. Should come in right at the end. I'll be able to test it out. We won't get the next version of the TPU ARM assembly printed in time, but we'll jump into that tomorrow morning. But we'll keep making some refinements here. So I think that's good. All right, so we've got our balling. I kind of feel like I want the hex interface to be a little tighter. So let's kind of jump back into there. Let's just make that 7.5. Just verify. Okay, so now let's just clean this up a little bit. think we'll just add little fillets in these corners. Just little things that'll make the part that much more durable. And so let's switch to the overhead here. And you can kind of see. So one of the things, it's a little bit of the consequence of the TPU, but in some ways it actually kind of mimics the rigidity of a full-size component in metal and aluminum, or steel and aluminum. Because nothing is perfectly rigid, but there's a little bit of that. It's not, this shouldn't turn, so there's a little bit of flexibility there, and you're never going to totally get rid of it, but I'm curious if there's a way to stiffen that up. My guess is it's by bridging kind of the tops of these two arms together so that they can't pivot independently, because you can kind of see, might be hard to tell without light. They kind of pivot separately. So I think one of the things we'll do is we'll connect these. This will break stuff, but that's okay. Let's see what this looks like if we... It didn't break anything. That's fascinating. So we just kind of basically added a bridge here so that we didn't have what is effectively a multi-axis pivot in between. And we could probably even stiffen that up a good bit. We could also make this section wider, would probably help, which could be kind of interesting. And if we really wanted to get crazy, we could add a little arm and a link and make the toe adjustable and also act as kind of a support. I wonder how you would do that. you could almost put a hole all the way through, and then you could use the rigid material as an arm that kind of pops in there. That could be interesting. And that would transfer that load all the way through that. I think what we'll do it's also looking a little bit clunky, I think, for a Thorne Buckingham thing. It should look a little more refined. So we'll just kind of looking at the clearance. I do kind of like the idea of essentially a little steering arm coming off that would then let you swap out the ball end link. You could almost build that connection for it too, like here somewhere. For now, let's just kind of clean this thing up. I almost feel like this just needs more draft. Here's an example of kind of adding fillets too soon. So let's see. Let's make these 0 for now. See if that breaks everything. Not too bad. Let's do the same thing here. I think that might be too much draft. Looks kind of nice. All these little kind of corner fillets and reinforcements go a long way toward making the part a lot more rigid. Like sometimes they all add up. Doesn't take much. A little bit of gusseting goes a long, long way. Alright, we're going to be dirty here. Just kind of softening these lines up a little bit, make them look less chunky. It's minor, but again, makes a difference. It's easy to miss some though. Just checking our part, looks good. You know what I might do though, while we're waiting, I might do a little bit of just some housekeeping stuff. So I don't like that this doesn't update as we make changes here, which is all because this is a copied tab. So we're just gonna, again, we're gonna be a little dirty here. We're just going to derive the flat pattern in so that it stays connected. Excuse me. Interesting. I have not seen that before. Cyclical references sounds like crossing the streams or infinite feedback loop and the universe gets destroyed, so that sounds kind of fun, but apparently it won't let us do that, probably for good reason. But I wonder if we just make a whole new part studio here. I'm not a fan of having the planes visible, they kind of distract me. I wish there was a way to default not show them. So let's see, can we derive it in now? Should be able to. All right, no universe ending circular references. Okay, so now what we're going to do is we are going to, well, first we're going to change these colors. Okay. Now we're just basically going to do what we did last time. We're going to split this thing up into pieces and rotate them around. Okay, so once again we should have 5 parts. And honestly, we can make it easier. Oh. Let's just use those, because that way if we do anything asymmetric, which we probably won't, but just in case, it'll, rather than deleting these, moving these and then mirroring them, we'll just treat them as independent and just go through the motions of transforming them. There we go. And just like last time, I'll have to give it a little connector sketch. extrude that. We'll add it. We're going to add it to this, 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 and this. And we're going to go up to face. And now we have one part that should update with any changes to the main flat part design that we're working on. But let's do something else here. Let's get rid of this piece. And let's insert our new, actually, let's go back. Let's just call this our A-arm folded. And we'll add a mate connector. Alright, so now we've got all the latest and greatest shapes and features, and that should update when we make changes to the flat pattern. And it looks like our part here is done. Let it cool a little bit. Let's throw some snap dots in it. Those aren't the right ones. Maybe use some orange ones for a little contrast. That's pretty good. Now let's just kind of disassemble this one. That's, I think, starting to look pretty good. I don't know if I have a... As for comparison. So not too shabby. And I don't know, I kind of wonder if we make Thorne Buckingham's trophy truck a single seater and kind of give him a little bit of an Iron Man-esque quality. He seems like the kind of guy that like wouldn't listen to a co-driver anyway, so he might as well not have one. Just one more person to kind of steal some of his glory. I'm just going to see if this isn't the spring we would use, but I'm kind of curious just to see what that whole layout looks like. Put it upside down, but cool. I think that is an excellent start. Oh, I think we lost. There we go. AI tracking got confused. How much time do we have today? Nope, about 4 minutes left. So tomorrow, what we're going to do is we're going to finish out kind of the detailing on this folded A-arm assembly. And I think the concept, today we proved out the concept. It definitely works. It's definitely going to be stronger. So I think we keep refining that tomorrow. I might even throw some features in here so we can experiment kind of with that toe adjustment, or like I'll call it a toe stiffener, even if it's not totally adjustable. Because if we can kind of do something in there that makes that stiffer, we can probably lighten up a lot of these A-arms too. May even throw some like stiffening elements into the TPU, which is something we do on like the trailing arms, because they're so long that you can't make the TPU thick enough to be stiff. So you kind of hide the other parts here. Oh, that's not what I wanted to do. We have the TPU element and the pivots, but then we have a stiffening component that snaps onto it to make the whole thing stiff enough. So the A-arms are generally short enough that that hasn't been really necessary. But we could stiffen them up considerably by adding like some stiffening plates to them as well. So that might be something we experiment with tomorrow. And then we'll get some springs in, and basically we should be able to wrap up tomorrow and get this whole front end design kind of wrapped up, and then we can move on to the rest of the rig. So yeah, thanks for the two people that did stop by, and then whoever you are, and it definitely surprised me. I was not expecting. I wasn't looking at the comments thing at all because yeah, I wasn't expecting anybody to tune in. Haven't really advertised it. I figured I'd just keep going, and maybe an audience eventually will come along. But also, it's the first one, so definitely not polished. But thanks for stopping by, whoever you are, and I'm sorry I didn't notice your comment sooner. I'll try to do better in that regard. But yeah. Designing a new ClickRigs trophy truck kit. Hopefully get it mostly done this week, and then get it into the store within a week or two. And yeah, so tomorrow, same time, same place, 8 to noon Pacific time, we'll be streaming the design of ClickRigs rig kits, and that's it. If you want to know more, check them out at ClickRigs.com. And we will see you here tomorrow. Have a good day.